Hello, I'm Peter from Aarhus University in Denmark. I want to tell you a little bit about the sensor board that we have developed, the Dul Radio. You can see it here. The Dul Radio is, due to its compact size, excellent for wearable purposes. And on the back side of the board, you can see a battery holder that holds a single button cell battery. It is very important that you insert the battery this way and not the other way, as it will ruin the board. On the front side, you can see analog inputs 0, 1, 2, and 3. Yeah, that's available through the software, and you also have some digital inputs on the other side of the board. You have the option of external sensors as analog sensors, simple analog sensors, and then you have an onboard 3-axis accelerometer. The accelerometer chip also contains a gyro. In the corner of the board you have the reset button. If you reset the board, there's an LED here and it will flash, as you can see here. The board has a USB port for programming, and it's Arduino compatible except for the accelerometer and special pinout. Here you can see a pressure sensor and simple analog sensor that has 2 wires connected to it, and you can connect these wires to an analog input on the one side and, for instance, ground on the other. We'll demonstrate that later on. The system also consists of a radio receiver that communicates with the radio boards from the PC, and this board is just an Arduino Uno attached to a radio board, a Chinese $1 radio board that is to be connected via USB to the host PC. To access the data from the Dul Radio, you need a piece of software called the Eventbus. Here you can see the Eventbus editor. It's a flowchart kind of software. To communicate with the Dul Radio, you have to add a filter. You do that by right-clicking in the gray area. You go down to Gadget and select Dul Radio 2. This is version 2. And you choose the Dul Radio 2 receiver filter. When you select the Dul Radio receiver filter, you can see some parameters to the left. You can see to which serial port the input board, the Arduino board with the radio receiver, is connected. In our case it's COM7. And then you can activate and discover Dul radios by pressing Discover. The fastest way to get the Dul radio board to respond is to initialize it pressing the reset button, and then it will appear in a list. You can select the Dul radio and press Connect, and it will appear in a list and be configured automatically. Now you have connected to the Dul radio board. It goes from red to black, and you can press the setup button, and here you can see further parameters for the Dul radio. First, the event identifier, which you can change to a more sensible name. In our case, we'll choose Dul Radio 1. You can see the update speed, meaning the data rate with which you read data from the inputs, and we'll choose 40 events per second. You can activate the accelerometer, and we'll choose plus minus 2G and set a threshold so the Dul radio will sleep when it's not activated by the accelerometer. And you can have the analog sensor inputs, and you will enable sensor 1, where I have mounted the touch sensor that I showed you before. And we'll add a threshold to that as well. and press apply. Now the board will automatically be configured, and we can add a debug filter. We'll go down to Dul Radio 2 and choose the debugger and connect it as a flowchart from one filter to another. And you can press the debug filter and you have some data from the Dul Radio, the accelerometer, and if I press the touch sensor you can see the analog input value changing for the first sensor. And after a while, battery level will appear in the lowest indicator. Now we can add another debug filter. Under debug you can find the frame debug filter. That'll show general debug options. Connect the frame debug filter. You'll double click it and another window will open. And if I move the sensor board, I can see the data from the sensors. Now we have seen the data from the Dul Radio in the Eventbus, and the next step would be naturally to send the data from the Eventbus to another application. In our case, we have made a simple demonstration in processing, so we'll need to get the data out of the Eventbus into processing. To do that, we'll need to filter the data. First, we'll add a filter to get the data from the accelerometer out, and that filter we'll find under Dul Radio 2 converters, and it is the Dul Radio 2 spatial 3D converter filter, and we'll connect that from the input. And on top of that we'll have the data from the analog sensor, the pressure sensor, converted, and we'll use a Dul Radio to analog sensor vector filter, and we'll connect that to the input as well. Now we'd like to send the data to processing via UDP, and we'll choose a filter called UDP send filter. Connecting the converted data to the UDP send filter, we'll get a pop-up, and the Eventbus suggests several options, and the option we need to choose in this case is spatial 3D to OSC converter filter, followed by the OSC to UDP filter. Connecting the converted data from the analog sensor to the UDP send filter, we'll get several options, and the one we need is measurable to OSC converter filter, followed by the OSC to UDP filter. Pressing the UDP send filter, you get an IP, so you can send to a local machine 127.0.0.1 or another machine on the network, and to a specific port. In our case, the processing application is using 7777. For debugging purposes, you can add frame debug filters several places in the graph, in the flowchart, and we have a frame debug filter here, and you can add filters like after the conversion. So we have frame debugging 3 places in the filter graph, and moving the sensor board and pressing the analog sensor. So on the 2 right-hand debug filters we have filtered out the analog sensor, and now it's viewable, the analog sensor and the 3 parameters from the accelerometer viewable in 3 frame debug filter windows. We've made a simple application in processing to visualize the sensor data coming from the sensor board On left we have the analog sensor, so if I press the analog sensor here, the window goes from white to black when it's fully pressed. And second, we have the first parameter of the accelerometer, so I can change the red color by rotating the sensor board, and that goes for the blue, the third parameter from the accelerometer as well, and rotating in another axis I can change the green color.